Hello guys, welcome back to the YouTube channel. So today we'll be discussing about set. So first, in order to use set, you need to include set in your program. So this is how we include set. Now if you want to initialize the set, you can use int s. Now we have a set which contain all the values of int type. And if you want to insert some element in the set, you can use this function s.insert and whatever element you want to give to it. So now we have s with the value 10. Again, if you use s.insert 20, then it will contain the value 20. And again, if you give as s.insert 20 again, so it will be not storing anything value. It already had 20, so it will just ignore it. So the values which we are having in set s is nothing but 10 and 20. Suppose we give is 30, then it will come here 30. So in order to traverse these elements, that is 10, 20 and 30, so here one more element is there, that is 20. So one thing we need to make sure is the elements which we are adding in set are in increasing order, like 10, 20, 30, because set uses self-balancing binary search trees, same as we discussed for maps in the last video. So they have self-balancing binary search tree, which makes the set to keep it elements in an increasing order. So if you want to print the elements in the set, you can use auto operator for that, and you can just cout x, so it will just print the elements in the set, that is 10, 20 and 30. Suppose if you want this elements in decreasing order, like 20, 30, 20 and 10, then you can use or declare this first using greater function, which makes in descending order, which makes s in descending order. So then now the values will be stored in this fashion: 10, 30, 20 and 10. So there is another way of accessing the element, that is using iterator. For that you can make iterator like set int iterator it. Now you can use for loop. It will start from it equal to s dot begin and it not equal to s dot end it plus plus, and you can just cout star it for that, for the elements. Now this is again one of the way of accessing the elements. And you can see if you want to find the element, like for example you have set with the value 1, 2, 3 and 4, and if you want to find that whether s is present in the set s or not, so you can simply use the find function s dot find 4 not equal to s dot n. Then in that case you can write cout found else not found, as simple as that. And again, in place of find you can use count, because we know that the set contain only the unique values. So you can write if s dot count 10 is there, so for this it will return false because there is no element 10 in this. So you can say cout not found, else it is found. So this is the use of find and count in this. Now you can use one other function, erase function. Erase and clear we'll discuss. So if you want to clear, then you can simply use s.clear to clear the whole set. And if you want to erase some key value, then you can use s.erase the key value which you want to remove from the set. So this again can be used for a range of the values. For example, s dot erase, and from some point that which iterator is pointing till some point, like you can say s dot end. So what it will do is, from iterator it till the last, it will delete all the values. So this is how we use erase function to remove the elements. And now if you want to use lower bound and upper bound, so what this lower bound and upper bound do is, so this can be we know that to use lower bound and upper bound, you need to have a sorted set. So being a binary search tree, it is already sorted, so we can use this s dot lower bound and s dot upper bound. For example, 10, 20 and 30 are some elements in the set, and if you use lower bound of 10, then it will show value as 10, and if you use lower bound of upper bound of 10, then it will show 20, because lower bound found the value which is exact, which is matches with the argument, and the upper bound gives the value next to the value which we are searching. So this is how we use upper bound and lower bound. And some of the mainly used uh, methods, or you can say functions, are begin, to find the beginning, end, and you can say is to use the size. We can find the we can use s dot size to find the size of the set, how many elements are there. For example, in some questions you are given like some vector 1 comma 2 3 like this, and you need to find how many unique elements are there. So you can just use set, so you can just store these values in some set, and you can just find the size of that set. So that is how you can find the all the unique elements in the vector. So this is again one of the question using set. We'll discuss more questions on sets and maps in the coming videos, but for now we'll be sticking to our like STL thing. So s dot size is there, then you can use empty function to find whether set is empty or not, and this all can be done in order of 1. So, and some other function like insert, and you can say find and count and erase, upper bound, lower bound, upper bound, lower bound, this all can be done in order of log n. This complexity is like is achieved by using binary search trees, self-balancing binary search, and more specifically red black tree, which the set uses. So I think that's it for today's video. We'll be discussing more questions on set, maps and vectors in the coming session, but before going to the question, I need to complete whole STL thing. So that's it for today's video. Thank you for watching, and if you like the video, just go and subscribe to the YouTube channel. That means a lot to me, and we'll meet in the next video. So till then, stay tuned.